Hi everyone, I'm so sorry for being late. I thought I figured out how to share my screen on my laptop, went through the whole presentation, realized I wasn't live, so here we are, 13 minutes late. Sorry about that. So thank you for joining for the last Facebook Live presentation of the 2020 school year. I just now realized that I hadn't introduced myself yet, so I'm gonna do that real quick. I'm Sarina Grijalva. I'm currently a junior studying optical engineering here at the U of A. And today I'm going to be talking about the electric pickle. So I'm going to pull up my slides right here. And you may be wondering, what exactly an electric pickle has to do with optics, or even what I mean by electric pickle. And as I'm sure you guessed, I mean quite literally running electricity through a pickle. And the electric pickle is actually a great way to explain the general concepts behind atomic emission, and what that is just this chemical analysis used to that uses the intensity of light emitted from either a spark or a flame or an arc at certain wavelengths to determine the quantity of the element. So the atomic emission spectrum are unique spectra of light emitted by an element. So once electricity is run through it. So in this case, we're going to be running electricity through these store-bought pickles, and it's going to produce a emission spectrum peak, primarily in the about 589 nanometers in the sodium doublet, and that's just because we know that pickles are made from cucumbers that are soaked in sodium, salt, and like water and vinegar and such. And because the salt, the sodium chloride, are ions, it means that they have positive and negative charges. So ideally, they can potentially conduct electricity once, that current is run through them, as we're going to do. So, and as I said, because the emission spectrum are unique, it can act as an element's fingerprint. So if I had soaked the pickle or cucumber in a different type of element, we would see a different peak in the emission spectrum and a different wavelength. So a little bit more about the pickle. We're gonna stick two of these metal conductors through it that are parallel to each other but not touching, so that once we turn on, give it some voltage, there's gonna be, the gap that's between them is gonna allow electricity to be conducted through the pickle, and then you're gonna see some sparks, and because it was soaked in sodium, you're going to see a yellowish orange type of glow, just due to those sodium chloride ions being excited. You may also hear a buzzing sound, and that's just, again, because the electrical arcs that are going between the two conductors. And then you may also notice steam, which is just because the water that's already inside the pickle is being heated up. And as I said, the emission spectrum is unique to elements. That means that if you're pickling with ions that are other than sodium, you're going to see those respective peaks and those colors when you heat it up. So for lithium, for example, if we soaked it in lithium, you would see the pickle glow like a pinkish color. In potassium, you'd see like a purple color. Strontium, you'd see more red, and for barium, you'd see like a yellow, which is just really cool because you can use this to compare different metal ions and their unique line spectra this way. And just want to say, in addition to observing the cool colors that it's gonna glow, you can use like diffraction glasses, or in this case, a spectrometer, to compare the spectra and verify the wavelengths. So that's what we're gonna try and do. But first, I'm gonna show you the pickle. I'm gonna go ahead and put this right here. Here are those two metal rods, conducting rods, and here's our pickles. And I'm just gonna grab one of them. They've already been pricked before, so I'm gonna find a new spot. I'm gonna stick it through, like right here. Oh, gets a little messy. Okay. And then I'm gonna go ahead and dim the lights before I turn it on so that it'll be easier to see. Alright, so I'm gonna turn it on. You can see the yellow glowing pickle and some of the steam that's coming off right here and the buzzing sound. So yeah, it lasts about like a minute or so. Yeah, I'm gonna go ahead and turn that off. So yeah, now I'm gonna scoot on over to this setup over here where we have, right here we have the Spectrum tube Carousel, which just has different elements. Here we have hydrogen, CO2, argon, and we're gonna look at the spectrum here, where on the y-axis we have the intensity, and then on the x we're gonna see the wavelength and the respective peaks. So I'm gonna leave this. Hopefully you can see both of them. Well, it's more important to see this. So first, or you know what, I'm gonna flip the camera. Sorry about that. Flipping the camera. Okay, so we have this type of sensor thing right here that we're gonna turn this on, and we'll start in helium once it turns on. Or maybe we'll do hydrogen. Oh, it's over here. My bad. All right, we'll start with hydrogen. And we're gonna just put that right there. And I'm sorry, I'm gonna get a new file going. This was when I thought I was presenting the first time. Okay, it's loading. So graph options, we're gonna do visible spectrum. Okay, so we have this right there, and I'm gonna press collect, and we're gonna see, I'll hold it right here. It's picking up the peaks, as you can see right there. I'm just altering this so that it picks them up. We can see 2 peaks at about 500 nanometers, and oh, there's 3 peaks, one right here, here, and then over closer to 700 nanometers for hydrogen. Then if we switch over to CO2, we'll look for the, oh, it's not turning on. We'll go to argon, sorry. Argon right there, gonna scoot that in and look for the peaks, whoa, which are well over here past 700 nanometers. Then if we did neon, we have neon, I'm gonna hold this right there. We see those peaks at about close to 600 nanometers in intensity. So what I'm gonna try now is I'm going to move this to the Pickle once the yellow color is showing, and we're gonna see if we see those peaks around 589 nanometers, which is about right here. So I'm gonna leave the camera right about here so that you can see that. I'm gonna turn the Pickle on, and then, sorry, I'm gonna turn the lights down real quick and see if we can see the peak. I'm gonna switch Pickles because this one's pretty used up, just so we can get more of the color to show. Okay, so turning it on, see the peak right there? I'm gonna try and pause it. sorry. Well, I couldn't pause it, but if you guys could see the peak was about, oops. The peak was around right about here, which is like 589 nanometers, which makes sense because this was soaked in sodium, and that's the wavelength that we expected to see. So yeah, so that's all I had to say about the electric pickle. Sorry about all the technical difficulties and the camera problems, but thank you for joining, and have a good, happy holidays and rest of the year. Thank you. Bye.